Have you ever woken up in the dead of night to the sound of rushing water inside your own house? It is honestly one of the most panic-inducing things you can experience as a homeowner. A flooded living room just feels like pure chaos. But welcome to this explainer, where we're going to transform that terrifying household disaster into a fascinating, highly structured, scientific breakdown. Today, we are looking at the hidden science of water damage restoration. We'll dive right into the exact chemistry of contamination, the precise math behind structural drying, and the strict professional protocols that literally stand between a total property loss and saving your home.
Let's quickly pull up our agenda. We've got a lot of ground to cover. We'll start with the Hamilton water thread, then move to the ticking moisture clock, categories of contamination, the science of drying, the three-phase rescue, and finally, navigating insurance and costs.
All right, kicking things off with Section 1, the Hamilton water threat, a multi-front war on homes.
To really wrap our heads around the anatomy of a water disaster, we need to ground this in a specific battleground. So let's look at Hamilton, Ohio. See, water disasters are rarely just random bad luck. They're actually deeply tied to local geography and seasonal weather patterns. Hamilton properties face these intense, shifting threats depending on the exact time of year, meaning folks there have to maintain a state of hypervigilance year-round. In the spring, the threat is all about sheer volume. The Great Miami River swells up with melting snow and spring rain, frequently overflowing its banks and threatening low-lying historic spots like German Village. It's this massive, highly visible force of nature. But then, winter brings a completely different, totally insidious kind of attack. You've got these drastic freeze-thaw cycles, silently working away at older plumbing. Deep in the unheated crawl spaces of historic neighborhoods like Lindenwold and Roseville, aging pipes freeze, expand, and just shatter in the dead of night. And summer? Well, heavy, sudden thunderstorms can completely overwhelm the city's older combined sewer system. When that happens, the pressure literally reverses, violently pushing contaminated water back up through basement floor drains. It is quite literally a relentless multi-front war on homes, changing tactics with every single season.
Moving right along to Section 2, the ticking moisture clock, the critical 48-hour window. So water might be the visible bad guy here, but the real enemy in any restoration scenario is time. The second water escapes its boundaries, a biological clock starts ticking loudly. In just the first hour, water doesn't sit there, it sprints. Through something called capillary action, it rapidly migrates up porous building materials, soaking drywall, ruining insulation, and creeping silently under floorboards. But things get infinitely more serious between hour 24 and 48. This right here is the critical threshold. If you failed to extract the water and drop the humidity within that specific 2-day window, microscopic mold spores, which naturally exist everywhere in the air around us, they find the perfect humid environment to settle down and start actively colonizing. What started out as a plumbing issue has now mutated into a biological hazard. Leave that moisture trapped for a week or more, you're looking at hidden structural rot. The actual wooden bones of the building start to fail, causing severe secondary damage that'll drastically multiply the cost and the headache of the repair.
Okay. On to Section 3, categories of contamination. Not all floods are created equal.
The actual anatomy of the water itself completely dictates how a disaster is handled. The restoration industry uses a strict set of standards known as the IICRC protocol, classifying water damage into 3 very specific categories. Now, this isn't just bureaucratic red tape. This classification entirely dictates whether your home's materials can be safely sanitized and saved, or if they have to be ripped out and thrown away. Category 1 is clean water. Think a broken fresh water supply line or a sink overflow. It's got a low danger level, and if you catch it quickly, materials can usually be saved. Category 2 is gray water. This is your washing machine or dishwasher overflowing. It carries a medium danger level because it contains some chemical or biological contaminants that could definitely make you sick. But Category 3, this is where things get deadly serious. Known as black water, we're talking toxic sewage backups and muddy river floods. Category 3 water is teeming with highly harmful pathogens, bacteria, and sometimes even heavy metals. You absolutely cannot treat a Category 3 river flood the same way you treat a Category 1 burst pipe. Trying to DIY a Category 3 cleanup with household cleaners is incredibly dangerous and exposes anyone inside to massive health and respiratory risks.
Let's dive into the math with Section 4, the science of drying, beyond wet versus dry.
Bringing a house back from the brink goes way beyond just putting a hand against a wall to see if it feels dry. Professional structural drying means hitting exact, mathematically calculated material thresholds. Different materials hold water differently. Take wood framing and structural lumber, for example. This is the literal skeleton of a house, bearing the entire weight of the structure. It has to be aggressively and continuously dried until technicians can verify the internal moisture content has fallen below 15%. Why 15%? Because anything higher creates a literal breeding ground for wood decay fungi. If the moisture stays above that magic number, the wood will eventually warp, rot, and critically compromise the structural integrity of your home.
But, a house is made of a lot of different components, and dense materials play by completely different rules. For concrete foundations, basement slabs, and heavy flooring, that target number plummets all the way down to below 4%. Concrete is super deceiving. You can sweep water off a concrete floor, and to the naked eye, it might seem perfectly dry, but deep inside its dense, porous structure, it can still harbor massive amounts of water. If a contractor lays new carpet or hardwood over concrete that hasn't hit that strict 4% mark, that trapped moisture will eventually wick upward, totally destroying the brand new floor from underneath.
And then we've got drywall. It's kind of ironic that modern homes rely so heavily on what is essentially a fragile paper and chalk sandwich. Drywall acts exactly like a sponge, wicking water upward against gravity incredibly fast. It is just so unforgiving. To guarantee that mold cannot survive within the walls of a living room, technicians have to intensely monitor the environment until that highly porous drywall reaches a microscopic level of below 1% moisture. It requires absolute dead-on precision.
This kind of scientific precision is exactly why the old shop vac and box fan method is entirely useless against a serious water event. You simply can't just guess if a room is dry. Modern restoration professionals use sophisticated thermal imaging cameras and specialized penetrating moisture meters. These thermal cameras act almost like X-ray vision for the technicians, highlighting cold spots where water has pooled behind baseboards or soaked into insulation. Hidden moisture sitting untouched behind finished walls or trapped under heavy subfloors is basically a ticking time bomb. Without the right diagnostic tools to find it, that moisture stays comfortably trapped in the dark, quietly feeding toxic mold colonies and slowly rotting the structure from the inside out, all while the homeowner assumes everything is perfectly fine.
Now let's look at the solution. Section 5, the three-phase rescue, the professional restoration protocol.
When disaster strikes, panic and helplessness are totally natural human responses. But professional intervention replaces all that chaos with a highly methodical, proven protocol. There's this profound psychological relief for a homeowner when a clear path back to normal is established. Phase 1 is emergency extraction. This is all about stopping the bleeding. Technicians use these massive, incredibly powerful truck-mounted vacuum systems to physically pull hundreds or even thousands of gallons of standing water out of the carpet and padding to halt that rapid capillary migration. Phase 2 is structural drying. This is where the science takes over. Commercial-grade desiccant dehumidifiers and high-velocity air movers are brought in to create a loud, hot, relentlessly dry windstorm inside the house. This equipment runs 24 hours a day, 7 days a week, usually for 3 to 5 days, to force the evaporation needed to hit those exact moisture percentages we just talked about. Finally, Phase 3 is reconstruction. Once the environment is scientifically verified as dry and safe, materials that were simply too saturated or contaminated to save, like raw sewage-soaked carpets or crumbling drywall, are professionally rebuilt, finally making the house a home again.
Lastly, Section 6, navigating insurance and costs, what your policy actually does. The scientific cleanup is really only half the battle. The financial aftermath is often just as stressful. Understanding exactly how this gets paid for is super practical, actionable knowledge for any property owner. When an insurance adjuster evaluates a water damage claim, they're looking for one very specific distinction. Was the damage sudden or was it gradual? Standard homeowners policies are designed to cover sudden, accidental events. If a winter pipe violently bursts in your ceiling while you're at work, or your washing machine suddenly blows a hose and floods the laundry room, you're almost always covered for the cleanup and repair. But the reality of a denied claim, that is painful and incredibly expensive. Insurance companies will almost certainly deny claims resulting from gradual damage. If you ignored a slow, dripping pipe under the kitchen sink for 6 months until the cabinet rotted out, or if groundwater naturally seeps through foundation cracks because of poor drainage, standard insurance will step away, citing maintenance neglect. Furthermore, and this is absolutely crucial for places near waterways, a standard policy completely excludes river flooding. If the Great Miami River overflows into a living room, a standard policy pays nothing. Homeowners in those areas have to proactively secure a completely separate, specific flood insurance policy to survive the financial hit of a natural disaster.
So, we've broken down the complete anatomy of a water disaster. You now understand that relentless, ticking 48-hour mold clock. You know the severe health hazards separating black water from clean water, and you understand the exact scientific moisture percentages required to actually save a building structure. Knowing everything you now know about how incredibly fast water destroys and how precise the recovery must be, ask yourself this final question. If a hidden pipe in your wall bursts right this second, are you prepared to act?